Welcome to Excellencia School of Chemistry. You're welcome to the discussion of the volumetric analysis of 2023 NECO SSCE. We've done a separate video on the qualitative analysis and it's already on this channel. And this is the discussion of the volumetric analysis. And may I invite you to please subscribe. Okay, just click the subscription button now before you continue with the video. Okay, so having done that, I want to also urge you when you enter the examination hall, ensure you read the questions very well, because these things are just like hypothetical. They are just guide. Okay? Now we have the following questions. But meanwhile, A is a 0.0500 mole per dm cube H2SO4 aqueous, and B is a solution containing 3.6 grams of sodium carbonate hydrated in 1 dm cube of the solution. A. Put A into the burette and titrate against 20 or 25 cm cube portions of B using methyl orange indicator. Repeat the titration to obtain consistent titer values. Tabulate your readings, your results, and calculate the average volume of A used. And below is the equation for the reaction. Now we have the questions here also following the subsequent questions here, but first of all, let's look at the table. So this is just what the table looks like. Now the endpoint must not be this, because each center has their own endpoint, okay? Or similar endpoint, it might be you just have your own endpoint, your own center. It might not be really exactly what I have here. This is my own endpoint based on the chemicals or the reagents that are used. But ensure you write the volume of pipette, 25 cm cube or 20 cm cube. Ensure you write the units, correct units here. Ensure you present your work in 2 decimal places, and the second decimal place must be either 5 or 0. Ensure that your volume of A used, your values are consistent, they are concordant. And concordant means that the difference between the highest value and the lowest should not be more than 0.2. And this is the average volume of A used as instructed. And we have the next question in the B portion. BI says concentration of A in gram per dm cube. So we use this formula, molar concentration, that's N. Amount is mass over molar mass. Okay, and the molar mass of H2SO4 is as calculated here. Please do not just import a value, you must show your calculations, okay? And then making M the subject of the formula, we have M equals to NM, N capital M, which is from the equation 0.5 yes, mole per dm cube, multiplying the molar mass, which gives us 4.900 gram per dm cube. And for the B part, we are asked to calculate the concentration of B. The II, we are asked to calculate the concentration of B in mole per dm cube. And using this formula here, and Ca is the concentration of the acid, Cb conc of the base, Va and Vb are the concentration of the volumes of the acid and the bases, and Na and Nb are the coefficients of the acids and the bases from the balanced chemical equations, as we can see them here. The coefficients are 1 to 1, okay? And having noted that, ensure that the concentrations you use here are in mole per dm cube. We don't use gram per dm cube here, okay? Now, making B the subject of formula, and I will strongly recommend you make subject of formula before substituting, okay? And we substitute as follows. All the values we got here, this is the VA is the volume of the average volume of A used, and the VB is the volume of pipettes. So this is the concentration of B in mole per dm cube. And we have the third question here, which says that we should calculate the molar mass of the base, NaCO3 hydrated. And we still use this formula again, molar number of amount, that is molar is equal to mass concentration over what? Over molar mass, okay? And in this case now we make the molar mass the subject of the formula, and so we substitute the amount from the question given us, amount, the mass rather of B from the question here, okay? From the question we see the mass is 3.6 gram, and we continue. The N is the molar mass, the amount rather. We've already calculated it. When we substitute, we find the molar mass to be as given here, 241.611 gram per mole. And if the question says relative molecular mass, then you don't have to include any unit there. The next question says we should calculate the value of x. The value of x, this value of this x. We have to calculate it. Okay? We use this. We express these things as shown here. 2 sodium, 1 carbon, 3 oxygen, plus x H2O. We equate it to the value, to this molar mass we got here. Okay? Equating it, we substitute the value of each element. Okay? Substituting. So we find from here to here to be 106. Of course, water is 18. Okay? So x 18. And we're looking for this x. So we just make x 18 the subject of the formula, which means that this 106 goes over. Okay, we have it equal to 135.611, and therefore we make x the subject of the formula by dividing the 135.611 by 18. Okay, we find x to be 8. Now you correct it to the nearest whole number, 8. And the final question here says the volume. The final question says the volume of carbon dioxide that will be liberated from the volume of B used in the titration at STP. May I say, urge you, if you have not subscribed, please do that now while we continue. Okay, so first of all, the volume of B used in dm cube, we use 25 cm cube of B. So converting into dm cube gives us 0.025 dm cube. The amount of B in that volume of B used, we have to find the amount of B. Okay, we use the formula CV. C is concentration, V is volume, and of course the concentration, we have already calculated it. The concentration here is the molar concentration, which we calculated to be 0.0149, and the VB is this volume here. Okay, so when we calculate, when we multiply them, we get the amount of B in the volume used to be 5.23 exponential minus 4 moles. And so we make the statement. You know, from here, from this equation now, the equation given us, we see that 1 mole of the base gave us 1 mole of carbon dioxide, okay? And 1 mole of every gas at STP, it occupies 22.4 dm cube, okay? So 1 mole of this gave us 22.4 dm cube. So we make the simple statement here that from the equation, 1 mole of B is equivalent to 22.4 dm cube of carbon dioxide. Therefore, okay, just a minute. Therefore, 5.23 exponential minus 4 moles will give us x. We make x the subject of formula here, okay, and substitute and get our answer. So thank you very much, and please ensure to subscribe to this channel and watch out for our subsequent videos. Best luck in your examination.